Welcome to The Explainer. So today we are unpacking a mystery that recently, completely sent shockwaves through the tech world. We're talking about the sudden, explosive rise of DeepSeek. Now, if you've been following AI, you might kind of think they just came out of nowhere, right? Like they just popped up overnight and disrupted the established titans of the industry. But as you'll see, they didn't. We're going to dive into a fascinating breakdown that proves this wasn't a sudden phenomenon at all. Actually, it's the result of a hidden, decade-long parallel history of global artificial intelligence development. It's a history that unfolded almost entirely outside the typical Western spotlight, operating under completely different rules. Let's dive right into exactly how this happened.
Now, there's an absolutely crucial distinction we need to make right from the start if we really want to understand this landscape. DeepSeek wasn't some desperate scramble to just catch up to Silicon Valley. Like this quote hits on, it's actually the story of China building something America never had to build. You see, while Western labs were playing a game with practically infinite resources, we're talking endless funding, unlimited processing power, massive data centers, Chinese researchers were playing a totally different game. They were forced to operate in an ecosystem defined by strict constraints. And as we're going to see, that specific environment breeds a completely different type of engineering philosophy.
Okay, let's start with our first section. 2 timelines, 1 world. We're looking at the divergence of AI development.
Think about the American strategy over the last decade. It was practically defined by pure scale, relentlessly hoarding compute power into these massive centralized data centers. Over here, AI was treated as this highly speculative frontier research project driven by a few major players trying to build, a universal superbrain. But the Chinese strategy? Vastly different from the ground up. They weren't just trying to build giant centralized brains, they were building resilient infrastructure. They embedded artificial intelligence directly into a massive, already existing digital economy, linking mobile internet networks, logistics, and advanced manufacturing. AI wasn't just an abstract research project, it was treated as a fundamental utility. Think of it like electricity or the internet itself. It had to work flawlessly across billions of daily interactions.
Watching this timeline play out year by year is absolutely fascinating. When OpenAI formed in 2015, Chinese labs were already laying this deep, practical industrial groundwork. And when the US pioneered that landmark transformer architecture in 2017, the tech that literally underlies modern AI, China didn't just marvel at it, they immediately adopted it as the exact framework they needed to handle the immense complexity of the Chinese language and scale their own national ambitions. By 2019, the divergence was super stark. While the US was centralizing power, think of the massive, exclusive Microsoft OpenAI partnership, China was deliberately federating its ecosystem into a highly redundant, widely distributed network of companies and state entities. Basically, one side was building a towering skyscraper, while the other was building a sprawling, interconnected city.
Moving right along to Section 2, Innovating Under Constraint, or how they ended up hitting the compute wall.
Put yourself in the shoes of a leading researcher back in 2021. You're facing this exact dilemma. How do you train a frontier-class AI model on hardware that is literally 2 generations behind the rest of the world? While American labs were going all in on brute force scaling laws, that mindset of just throwing more servers and more compute at every single problem to get better results, the situation in China was hitting a crisis point. Tightening U.S. export controls and lagging domestic microchip production completely broke that brute force formula. They simply couldn't buy the chips required to play the American game. They had to find another way to achieve world-class intelligence without world-class hardware. No way around it.
And this massive roadblock forced what became known as the efficiency pivot. Hardware constraint wasn't a fatal flaw here. It acted like an intense pressure cooker. Think of it like being forced to build a championship race car, but you're only given half the fuel of your competitors. You literally can't just put in a bigger, thirstier engine. You have to innovate. You got to make the car lighter, highly aerodynamic, and incredibly efficient. So Chinese engineers aggressively explored technical concepts like sparsity, intelligent routing, and extreme compression. They shifted their entire focus toward drastically reducing inference costs, which is basically the day-to-day cost of actually running the AI. Because they had no other choice, necessity truly became the mother of invention.
Then, boom, late 2022, ChatGPT arrives. It sent an absolute shockwave through the Chinese tech sector, triggering massive giants like Baidu and Alibaba to rapidly launch their own generative products. But beneath the surface, there was this stark realization. They simply could not match the raw computational scale of the US to keep this up. And actually, counterintuitively, the real catalyst for their next massive leap wasn't just a hardware workaround, it was regulation. In 2023, China released strict interim measures for generative AI. Instead of stifling innovation, setting these hard boundaries provided intense clarity. Labs basically stopped trying to blindly copy the boundless US models. Instead, they shifted entirely, laser focusing on cost per token reduction and engineering the smallest, most efficient architectures possible. Which brings us to Section 3, the DeepSeek breakthrough, engineering a completely new kind of model. To really grasp why DeepSeek eventually stunned the world, we need to understand a concept called sparse mixture of experts, or sparse MOE. Because computational power was treated as a scarce, precious resource, DeepSeek couldn't afford to activate a massive neural brain for every single question a user asked. Instead, they relied on intelligent routing. Think of it like a massive corporation. Instead of pulling every single employee in the whole company into a meeting to solve a highly specific problem, you only route the question to the 3 specific experts in the building who actually know the answer. By relying on an army of smaller, specialized models and scaling them horizontally, they achieved cutting-edge, frontier-level reasoning, but at an absolute fraction of the hardware cost. And this is exactly why DeepSeek was not just a Chinese ChatGPT. It really wasn't a copycat, and it certainly wasn't a desperate catch-up play by a lacking industry. It was an entirely different species of model born entirely from scarcity. And when it launched, it proved something genuinely revolutionary to the entire global industry. World-class artificial intelligence does not actually require infinite venture capital, infinite energy grids, or massive endless fields of computer servers. It proved for sure that brilliant, highly constrained engineering could go toe-to-toe with sheer overwhelming scale. And that leads us to our final section, the Great Convergence. What happens when these two timelines finally intersect? Suddenly, we're looking at a deeply bipolar technological landscape. On one side, as you can see, you have the American frontier, driven entirely by compute abundance, a philosophy of brute force, and massive centralized megamodels. On the other side, the Chinese frontier, driven by severe hardware constraint, a philosophy of hyper-efficiency, and highly specialized architectures like sparse MO. The explosive arrival of DeepSeek essentially forced these two completely isolated worlds to violently collide. Western labs weren't just looking at DeepSeek's methods out of scientific admiration. They were looking out of urgent, immediate necessity. The fundamental economics of the artificial intelligence industry had changed literally overnight, and everyone suddenly needed to figure out how to do a whole lot more with a whole lot less. But what's crucial to understand here is that this convergence isn't a geopolitical victory. It's not some dramatic story of one nation defeating another in a technological Cold War. It's a mutual realization. The global tech landscape woke up to the fact that the future of this technology, the everyday tools, assistants, and software we will all rely on tomorrow, demands both the American pursuit of massive, ambitious scale and the Chinese pursuit of relentless, microscopic efficiency. You need the brute force to explore the frontier, but you need the hyper-efficiency to actually make it accessible to billions of people. DeepSeek simply served as the inevitable bridge between those two distinct philosophies. So what should we take away from this entire parallel history? Well, it proves that human innovation isn't always the product of endless abundance and infinite resources. Sometimes the most breathtaking advancements are born strictly from intense limitations, which leaves us with a massive lingering question for the future. If constraint truly is the mother of invention, what other incredible global breakthroughs are currently waiting to be discovered, not because we have everything we need to build them, but exactly because we don't? Thanks for exploring this fascinating journey with me today on The Explainer. Catch you next time.